customers at Winky Donuts between 8 a.m. and 9 a.m. is believed to follow a Poisson distribution with a mean that's mu equal to 4 per minute. Was the probability of exactly 15 customers during a 4-minute interval. So this is important because it changes the mean. It's 4 customers per minute. So if it's 4 minutes,
Okay.
so your mu becomes 16. Now the kind of the awkwardness here is sometimes instructors incorrectly use the parameter mean and lambda interchangeably. They're not, but sometimes they do. So you want to use the Poisson, and because it's at an exact point, you want the PDF of that, and that's going to be in your calculator for that. So do you need me to show you where that is?
I might. I don't remember exactly how to get there.
I'm going to get mine up. Oops, I'm going to share a different screen, not stop. There it is. Okay, so it's under vars, it's second distribution. And you want the Poisson distribution. There it is. Poisson PDF number 8. And I don't even know what it wants here. I'll assume it's mu. And then it probably wants X. And then I'll see if that works. There it is. Okay. So 0.09922, that looks correct to me. But again, let me try this other one here. I don't know why it would be 1/16, but let me try that just to make sure that answer isn't there. Nope. Okay. Yeah. So it looks like it's a Poisson PDF. Mu is 16 and then X is 15.
Okay.
So let me go back and share that other screen. So you can see that. So this 8 a.m. to 9 a.m. is irrelevant.
Okay.
There's another question they could ask, but that's not important. You know, the conversion though is important. If it said 15 customers arriving during a 1-minute interval, you would use a mu of 4 because you wouldn't have to change this.
Okay, that makes sense.
All right, so the next thing is, let me go back, get that. All right, so 17, okay. All right, so I'm grabbing 17 here. Okay, so it says the number of customers is normally distributed with a mean of 25.5 and standard deviation of 6.6. What percentage of bills will be between those two numbers? So normally distributed means a Z or a T.
Okay.
The answers aren't that close, so it probably doesn't matter. This is a poorly written problem because you don't know whether it's the population standard deviation, which would make this sigma. It looks like we should assume that this is a Z distribution.
Okay.
And your calculator will do that. It will do you want a normal CDF. So it's in that second, that place we were previously. It's going to want the lower bound, comma, the upper bound, I think, the mean, and then the standard deviation, like that. You just got to be careful of getting the right order for that. Do you want me to show you this in the calculator?
No, you're good. I was just typing it in.
Okay.
And then it will,
Yours probably has a screen though that says,
yeah, and I get to just type them all in.
yes.
It's 0.3874, so then that's
So you multiply by 100 and get that one.
okay. Perfect.
This one is written slightly better on question 21 here. If there's a different order, just let me know. I'm just doing them in the order they came in.
Yeah, you're
to the
good.
email. Okay. So here they're better about it. See how they say mu and they say sigma?
Yeah.
That's a normal CDF. And they give you
Okay.
the lower and the upper. There is one difference here, which is that this right here, this plays into it. So your sigma, you do it up here, your sigma is actually sigma divided by the square root of n, but your calculator will do that for you.
Okay.
So here's the lower, here's the upper. These are the bounds. The mean is 815. The sigma, though, you would write it this way. You get 45, and your calculator will take this slash SQRT 38, and it'll actually calculate that. So the square root of 38 is like around 6. 45 divided by 6 is, I don't know, it's 8, a little below 8. So you'll see a number around 8, I guess, when you do that in your calculator.
Okay. And then I get 24, or sorry, 0.2422.
Okay, so a lot of A's right now, but they're auto-generated, hopefully, so that you shouldn't read too much into that.
Yeah, no.
It's bad when you don't get a number that's your, so that would be my main concern if there was if you got something that wasn't there at all. All right, question 12. This is 12. I'm gonna try snipping this differently, see if it fits the window better. All right, so this is 12. In a large university, 82% of students live in dormitories. A random sample of 8 students. What is the probability that the sample contains 8 students that live in dormitories? This is a binomial distribution.
Okay.
It is assumed, and probably wrongly, but that's just the way it's written. You either live in a dormitory or you do not.
Okay.
We know you could live in lots of other places. So, but what you're looking for is a p-value, an n-value, okay? And then the probability that x equals, in this case, it's 8. So that 8 is there.
Okay.
That 8 is there and that's there. So you have to know that the binomial distribution requires a p and an n.
Yeah.
Okay. So your calculator binom PDF, and I have no idea what order the inputs are. Let me think.
I can find it in 1 second.
Yeah.
I know PDF, it goes trials, P, and then X value.
I'm sorry, one more time. I didn't follow that.
Trials.
Trials. Okay, so trials, P, and then X. So I think of trials as N. So for
Okay.
you, that'll be 8, comma, 0.82, comma 8. This is the one that you want. And the reason we're doing a PDF, I guess I didn't say much about that in an earlier problem. It's because it's exactly 8. If it said
Okay.
more than 8 or less than 8, we would do something totally different.
Okay. And then I get 0.204414.
Yeah, so again, A. Okay, 18 is the next one here. You were asked to bid on a first edition copy of a book. You're bidding for a friend, and the friend gives you this much money. And then you keep whatever's left over. And if you lose, you simply return. Okay. Okay. Uniform. Okay. This is odd. This refers to exhibit. So okay. So if you want to maximize your profit, what bid should you submit? Feels like you must have had a class like, or a question like this. A question like this in class, maybe, because like this part is somewhat useful. The expected value of a uniform distribution is the average.
Okay.
Because this is a really odd question to just sort of throw out there. So the average is 12,400. Looks like it's 6,200, maybe.
Yeah, 6,200.
Okay, so that's what we expect. Like, we expect the cost to be 6,200 on average. And you want to maximize your profit. So the revenue in this case is 11,600 minus the price you pay. 6,200, maybe 5,400. Then you would have a negative. I'm not really sure how to proceed, so I'm gonna seek the world of Chegg and see if they have a similar problem here. All right, and the exact question does show up.
Okay.
So what they do is they find the expected. No, they don't do that. What do they do? Lovely. So the first one, they don't, it doesn't actually, they don't, the person who answered didn't use the numbers. Oh, wait, there it is. Oh, this is a slightly different problem. Yeah, okay. I don't know how important is is the answer to this?
That was one that I wasn't able to find online.
Yeah,
Not online. That was one that I wasn't able to find the answer to. So it's only 1.25 points. So it's really not that important.
I mean, if you want to guess here, I mean, you were talking about, you expect the book to cost 6,200
Okay.
approximately. So you want to keep as much of this money as possible. So if you bid less than that, I mean, let's just take an example here. Let's say you bid 5,600. Well, that means you get to keep 6,000.
Mm-hmm.
Okay. But if you bid exactly what the one that's right in the middle there is, you would get to keep 5,400.
Mm-hmm.
And so that answer isn't there. But would you be willing to bid more than this? I think you would. Okay, so like, what happens if we go up from here? Like, let's say we bid 6,600. Well, then you only get to keep 5,000.
Okay.
So like what is a reasonable number to guess on a problem like this? I mean, I mean, just logically at some point you would, so you wouldn't, if you bid the whole thing, like if you bid $10,100, okay, then what do you get as a profit there? 10,100. Okay.
I like 150. Wait, no.
You keep 1,500.
Yeah.
Okay. And then at the other extreme, so let's go to the other extreme. The other extreme is you somehow could get it at 2,300. So the other extreme is, what is that? 9,300. So what's the average of these two? That's probably where it is. 10,800, 5,400. Not an answer. Okay.
Should I just go with
You know,
650 because it's closest to what we got?
sure. I was gonna say that. You could also just, flip a coin between two answers. I don't have a good
Yeah, that's fine.
thing for you on that. So if you have any notes from class, my guess is there is a problem like that there that we could look at.
I just don't remember when this was from, like what part of class it was from.
Yeah, it's something with uniform distributions, but no big deal. So random sample of 33 lunch customers sample, average time was that, standard deviation was that. Okay, so standard error. Standard error
What
is
number
the
was this
standard
one?
deviation. Let me get that. Sometimes they don't step in. 26.
Okay, thank you.
So standard error, it's really a long question to get the standard, which is the standard deviation divided by the square root of it. It's 10.8 divided by the square root of 33.
Oh, that's all you do?
That's all it is. Like it's very deceptive because it's there's not much there to do.
And I got 1.88003.
It's like that one.
Okay.
Standard error. Yeah. All right, so next question. I lost track of where we are. Just did that one. Okay, 25. Okay. This is 25. All right. In order to estimate the average electric usage, a sample 144, that's N, had a mean of 2,102, that's X bar, standard deviation of 302, 99% confidence interval. Okay, so this is a T distribution, although you could probably argue that it's normal because that's so high. The degrees of freedom is 302 minus 1, and C is 0.99. But since you want to do a two-sided one here, these are lower and upper, you end up your alpha here is 0.01, but you divide it by 2, so you get 0.005. The confidence interval is X bar plus or minus T alpha over 2 comma your degrees of freedom. So we got to get this number times S over the square root of N. So you actually have all this information. It's 2,112 plus or minus. We got to get this number. And then your standard deviation is, oh, I'm sorry. I gave you the wrong number. Our degrees of freedom is 144 minus 1. And so your standard deviation is 302 over the square root of 144. I don't remember if the calculator does this. I don't know if it's got a built-in confidence interval. I think it does, but I couldn't tell you for sure. Let me look here. So it does have a T interval, which is what we would want. Let me go to stats. Okay. Yeah, so let me actually show you to do this on the calculator. I think this will work. New share. All right, I'm going to share the calculator. So I went to stat this time, tests, and then I went to T interval right there, number 8. And again, you probably could argue it's a Z, but they'll be close enough. You have to choose between data and stats. Stats just means you already have the numbers. So your X bar is 2112. Your standard deviation is 302, but you have to divide it by the square root of n.
Okay.
And I'm sure that answer without the square root of n is in there. Your number of samples is, I wonder if it calculates it for you. I wonder, let's see here. It may take care of that. These are all these unknowns that I don't remember, because I don't even use this. Like if someone came to me, I would use something else. See how that interval, those answers match?
Yeah.
So my guess is that the T interval, you don't have to divide by the square root of n on your SX. It will do that for you. Like that. If we don't get anything here, I guess I'll go to a different calculator. Yeah, and that matches what you've already got here selected.
Okay. Okay.
All right, so next number here is 24. I'm not sure if I'm sharing. Let me share the other screen. All right, so 24 here. So it says, what is the predicted value for living expenses when income is equal to 75? You're using this information down here. Specifically, it's the intercept 29.5. It's okay to round that, plus 0.4403 times your income, which is 75 in this problem. So this is 75, and you just have to plug this into the calculator there like that. I got one handy also, so I'll try this for you.
Got 62.5225.
Yep, same thing for me. Yeah, 62.52. Should have units on it, but it doesn't.
What number was that again?
34, sorry, not 24.
Okay, I was gonna say, I think
Yeah, you didn't send
something
24.
got mixed up.
Like, Matthew, come on. Yeah. All right. We could spend a little more time on 18, or do you have some other questions you'd like us to look at?
Was that all of them?
Yeah, please double check. I think it
Okay,
is.
I
I mean, I
think
just went in order.
there's one that I need. Let me see. Yes, I'm gonna send one more over if you don't mind. Oh, I got this one. Okay, I just sent one more over.
All right, let me take a look. Do you have any plans for the summer internship, school, or what do you got going on?
Just relaxing for now.
All right, I like that.
Yeah, ready to be done.
So this is essentially, it's written poorly. It's asking for the standard error. Let me snip it in here. And I had to infer that from the answers because it's really poorly written. So the standard error, I know it says standard deviation of X bar, that is standard error. So it's the standard deviation divided by the square root of n. It's 55 divided by the square root of 43.
Okay, so when it says standard deviation of X bar, that means standard error, right?
Yes, because it's not referring to mu. I mean, it's a very small distinction that you don't need to care about in your life, but like for the pure statistician, like it's hugely different. All you need to know is that it's S divided by square root of n, and it's 8.39.
Okay. Perfect. Let me just make sure I've solved that.
It does look like in a lot of these problems, they give you extra information.
Yeah.
You know, that could be very overwhelming to know what to throw out and whatnot.
Okay. Other than that, I think that was it.
Okay. Do you want to spend any more time on any other problems?
No, but I just checked number 18 and the correct answer is 6,950.
Okay. Well, I wonder how that came to be.
Honestly, that's fine.
Okay.
I'm fine with that.
Yeah. I mean, I could tell you that you said 6,950.
Yeah.
So just looking at the numbers, 750 is, so 11,600 minus 10,100 over 2 is 750. And we already know that that was 6,200 plus that gets you to, now why does that work? I don't know. I couldn't tell you. But if you want to spend more time, if you get another, I'll bet you can work it out the same way if you get another problem like this with similar numbers.
Okay. Other than that, I think I'm good.
All right. Well, thank you again for scheduling. I'm glad I got to help you tonight and hope you
Yeah,
enjoy
thank
your
you.
evening. Have a great one. Bye.
You too.